Hello everyone. Today we will discuss the function f of x is equal to x square is surjective and injective or not from the function natural number to natural number. Okay. So what is the meaning of injective? Injective means 1 1. So the meaning of injective means if you take any domain, so in this question the domain is a natural number, that means 1, 2, 3, 4 and so on. And codomain, that is also natural number. So that is also 1, 2, 3, 4 and so on. So 1 1 means if you take any element from the domain, it has a unique image in the codomain. It cannot map to two different images. That is called 1 1. Okay. So if we look at this example here, f of x is given to be x square. So this is our natural number as a domain. Codomain is also natural number, and our function is defined like this: f of x is equal to x square. So we have to take the input from the natural number. So if we take the first element from the natural number as a 1, so f of 1, so output we will get 1 square, that is equal to 1. So the 1 is mapping to 1. Then if I take input as 2, so f of 2, that will be 2 square, which is equal to 4. That means 2 is mapping to 4. Okay. Similarly, if we continue in this manner, then f of 3 will be 3 square, that will be 9. So 3 is mapping to 9. That means if you take any element from the domain, they are mapping to different numbers to the codomain. That means the image of every number is unique. So we can say this function from natural number to natural number is 1 1. But how to prove that in mathematically? So to prove f is 1 1, 1 1 means injective, we can say another way. We have to take two elements from the domain. Okay. Either you can choose x1 x2 or you can take x and y also. So let x1 and x2 belongs to domain. As our domain is here natural number, so we have taken two elements x1 and x2 belongs to domain natural number from the domain, such that if f of x1 is equal to f of x2, this is another way of saying if the images are equal, then that element also must be equal. Okay. So f of x1, so the value of f of x, the function is given to be x square. So the value of f of x1 will be x1 square is equal to f of x2 is nothing but x2 square. We know that it is 1 1, so we have to prove that. Okay. So if we take this x2 square in the left hand side, so we will get x1 square minus x2 square is equal to 0. So if you apply a square minus b square formula, so what we will get? x1 minus x2 and x1 plus x2 is equal to 0. So this is the bracket, two brackets are multiplication, the multiplication is 0. So when this is possible, the multiplication of 2, so that means we can say either x1 minus x2 is equal to 0, or we can say x1 plus x2 is equal to 0. Correct? But this second condition never hold, because we are dealing with the natural number. We have taken both x1 and x2 from natural number. So in the natural number, if you add two numbers, so the addition never 0. So this condition not possible. So only one condition is there, that is x1 minus x2 is equal to 0. So from that what we can say? x1 is equal to x2 for every x1 and x2 belongs to natural number. Okay. So therefore we can say f is 1 1. Okay. Now look at the second part, that is surjective. So what is the meaning of surjective first? So surjective means if you take any element from the codomain now. Okay, let's say this is a domain, natural number 1, 2, 3, 4 and so on. This side our codomain 1, 2, 3, 4, 5 and so on. So we have seen that if you put input as 1, then 1 is mapping to 1, then 2 is mapping to 4 and so on. 3 is mapping to 9. Okay. So what is the range set? Range set means whatever the images, collection of all the images. So if I collect the image set from the codomain, So we are getting 1, 4, 9 and so on. Okay, so codomain onto means if your range set is equal to codomain, then only we can say the function is onto. Means there is no number which left behind in the codomain without mapping with domain. Okay, if any number is left here without mapping, then you can say it is not onto. And the second thing is, otherwise you can check like this also. If the range set is not equal to codomain, then we can say the function is not onto. Okay, so you can see there here here 2 is missing without mapping, 3 is not mapped. Okay, means there is no number in the domain such that if you take the square, so you will get 3 or you get 2. Understood? Means there is no inverse image of the 3 and 2. 5 is also not mapping like that. So how to prove that? Okay, so to prove it is not onto, we to take one element, let x belongs to, or we can take let's y belongs to natural number. Okay, our function is from f from n to n. So now we to take one element from codomain. So we have taken one, let's say codomain, one element y from natural number codomain, such that f of x is equal to y. Okay, so if I put the value of f of x, that is to be x square is equal to y, then x is equal to what we will get, plus or minus root y. Okay, but y we have taken from where? Natural number. Okay, but x is equal to what we are getting, plus or minus root y. So this type of number cannot belongs to the domain, because x must be in domain. Or in another way we can say, by if it is not onto, so we can give counter example also. Let's say 3 belongs to natural number. Here we have taken in general y belongs to natural number, so let 3 belongs to natural number. So there does not exist any number or any x in domain such that the x square is equal to 3. Okay, x square is equal to 3 means x is equal to root 3, but this type of number is not there in the natural number. Okay, we are getting here x is equal to root y. So there does not exist any x in the domain such that f of x is equal to 3. Okay, so thus there are some element in the codomain, they have not inverse image in x, so we can say therefore f is not onto. Okay, I hope you are getting this. Okay, thank you very much.